Okay, so for this lesson I am going to look into a couple things. DHCP, I'm gonna look into DNS, and I'm going to look into VLANs and of course routing in general when it comes to setting up, you know, our environment, or if you were setting up a company or etc. We would like to have, you know, routing happen and certain things to happen that wouldn't happen if we did not configure them. DHCP doesn't happen magically on its own. Maybe we would want to have separate networks based on a VLAN, and we would like to make sure that certain devices can talk to each other but others don't. And in order to do this, we are going to start with just the basic premise of what this is all about, which is setting up a server and setting up a computer. Now, I think in real life, since I have servers here at home, I know that it is just perfectly fine to connect a computer to a server, but for some reason it does not work when you, in Cisco Packet Tracer, put in a just a regular computer into a server, which is why we are also today adding a switch. Now, not that it is bad, because we're going to be doing VLAN, and VLAN is an attribute of the switch, but we will right now, of course, also of a router, but we're gonna do this right now with a switch. And so what we do is we put in our cables, Ethernet to, I'm gonna go fast Ethernet 2 for now, because I want the one to connect to the server. This is right now not very important, but of course we need to make sure our cabling is correct. We would do that as well in real life. I press forward to make sure these are green and activated, so I don't need to wait all the time until this is set up. Okay, so we have these now connected, and what we can do now is we can go into a computer, and we go to a server, and we can go into services. We have HTTP. One of the first things we're going to do is change Cisco Packet Tracer to something like, for example, this is Facebook. Just to be so just to make sure that we know that this actually works, we're gonna save this as well, because if we just take the regular one, okay, it might work, but is it really? There might be something wrong if we put in something here ourselves. We make sure that we know if we are contacting this website that it will actually be giving the one that we created, which could be Facebook. This is just pure HTML. If you want to learn about this stuff, you need to do some web design. This isn't very hard. This is the basics of the most mock-ups when it comes to, you know, making a page in general. Many computer systems use this sort of you know, mock-up of markup or makeup of a website. So we have HTTP, they're on HTTP and HTTPS, which maybe you know or don't know. HTTP is unsecured, HTTPS is secured, that's why the S is added. This makes sure that your packages, when you're sending them, that they are secured, so that they're encrypted, so that if someone's, you know, you can do a man-in-the-middle attack. You know, if you have two computers between each other and you put an extra device in between, someone might intercept these and change the messages that you have been sending, or fake that you are on a certain website while you're on another website and stuff like that. This is why we have both. We will just be using HTTP. You know, we're just doing a simulation. So this is, and this doesn't have to be secure for now. We have DHCP. We don't yet really have any sort of pool, but we can set this on, so we can use this already on this device or computer here. Now, of course, the default 192.168.1.1 we're going to use. This is like general. This is usually what your computer at home is going to be or going to have as a IP address, because home addresses usually work the same. This makes it easy so that if you set up like something like a server, several websites, all these sorts of stuff that you can set up on your your network, that makes it replicable. If you set something up at home, you can set this up anywhere and they'll all have the same IP addresses, and it saves IP addresses because there's not many IP addresses. When the IP addresses were invented, they didn't think they would need or have would ever need that many devices. Of course, we're running out. That's why we have IPv6, but that's not a standard yet. And that makes sure that we have more devices. But right now, the way they solve it is by making sure that your home or any sort of environment has basically kind of the same IP addresses, local IP addresses, that make it easy for you to set up. I don't think it's necessarily intended so that you can replicate your environment anywhere, but it is a benefit of it. If you would end up with IPv6 and everything is in every home is something completely different, setting up your devices, if you're like, for example, migrating server systems to another area, that might make it so that it is more difficult to do so. DNS server, we're gonna take the exact same thing because we are going to set up this computer as a DNS server, and the IP address start 192.168.50, and we are 1 and then 50. We'll leave some space on our IP addresses to make sure that other devices can be added below that, like other routers, static computers that have an IP address that we are going to assign ourselves. We're gonna make sure that this is added, and our subnet is just the regular 255.255.255.0. We're not gonna save anything, change anything else. We're gonna save this, and what we are going to do is we are going to go to our desktop IP configuration, and we're of course going to make sure that this device is our first device. The default gateway is itself, and then I think maybe at some point we're gonna change this. I remember last time I made a mistake here that the default gateway when it comes to DHCP, but we'll see that later on. I hope I remember. Last time I ran into an issue where I forgot that I needed to change it, but right now I'm just doing the regular one. The server itself is its own default because it doesn't really matter, and the DNS of course is just again itself. This is just self-referential, but if we add another router, we're gonna need to change this to 2 because the default will be the router on the network, so it can communicate with the larger WAN or internet in general. We are going to check. We've set this up. Do we need anything else? DNS might be a good one. We're gonna create facebook.com, and the address of it is of course the server itself. DNS means domain name system. When you go to a certain certain service like GoDaddy, Squarespace, sorry, all these sorts of websites give you the ability to buy a domain name system. Facebook is a domain, YouTube is a domain, and you can buy these names and refer, as we have done here, refer to them on a certain IP address, so that when someone looks up that specific domain like Facebook, YouTube, etc., that they know where the server is. So you connect through this domain name server system, which is this device that we set up, that it will connect to that device and then give in return the domain name. So the name where this is stored, so that it knows where the IP address is. You know, this is kind of like you have an IP address is basically a phone number. If you have a phone number, it also has these 4 numbers, and then it has added to it like the location number, like where is it located. This is exactly what it is. You are phoning your server and then trying to reach a web page. Now, it would be a nightmare if we had to memorize all the phone numbers of every website in the world, like YouTube or Facebook. So there's a system that makes sure that we can type in this address and then find it. We're gonna close this. I think we've set everything up. They are on by default. And then we are going to go to the configuration of our desktop. In config, I can just normally turn on DHCP, and as we can see, we've got a default gateway, a DNS. If I look at configuration, we can see our IP configuration on desktop. IP configuration, we can already see the first address that we said we could start making IP addresses from was 50. Subnet mask is the one that we set, and the default gateway and DNS server are this device over here. Okay, we've set that up, which means I don't need to close. We've set that up. We can now ping this device. We're getting a reply from our server. Everything works perfectly. What we can do now too is we can go to our web browser. And this one usually takes some time to load. And now we can add this IP address of the default, and we will find our Facebook page. So what we did is we have our server, we turned on the HTTP, which is on by default, but we know for sure that this worked as we intended because we changed the page to say Facebook. Now we set up this Facebook domain name system, which means that now I can also look this page up with facebook.com. Now first I need to make this error out. If I can. Stop. Maybe I'll close it for a second. Reopen. Because the thing is, it's not very clear. We already were on that page, so did it really work? I can actually go to facebook.com. Normally, I think sometimes you can trigger like an error message, but at this point it was not giving me one. So I can go to facebook.com. I think I forgot something. If I go to services, I didn't turn on the domain name system, so make sure that this is on. I caught that immediately, and now what we can see, we can go to facebook.com. So that is what our DNS server, our DNS system does in our systems. It makes sure that we can give the name and don't have to give the number. And that makes it easier for us to find a website. Now, what is the next thing we're going to do is of course, we want to have PCs that are connected to the wider or broader internet, but we also want to have devices that are just connected to each other. So what we're going to do right now is we are creating two devices, two switches, and we're gonna set up a VLAN. We don't want certain computers to communicate with each other. We want to make a LAN, VLAN, local area network, a local network that's connected with each other, but maybe not with other devices. This might be a security thing, like you want to have servers that make backups of the systems, or have separate data information that's secure and doesn't in any way need to communicate with anything else on the internet. Maybe it might be, for example, if you have a security system and you have cameras in your building, you don't need those devices to have those videos connected to the web. That's the only thing that can happen in such a case is like big trouble, and someone finding the videos and using them or spreading them around. So we want to make sure that we don't have this sort of issue. I'm setting this up here. I'm going to create a virtual LAN system. Some of our devices I don't want to be able to connect with this server or with anything else in general. I'm going to use these in the middle to do so, and I need to make sure that they are connected. Now the cabling doesn't really matter right now. Usually best to just make sure that they're connected in a way that is logical, that doesn't confuse, but we're going to connect these, not these, and then this one, and then we're gonna go here, and then the last one over here. Now, as you can see, I can see which cable is connected to what. It says FA, fast Ethernet to whatever. Again, I've said this before, but in preferences, you can turn this on with always show port labels in logical workspace. If I disable this, they are gone. If I enable it, they are there. And this makes sure that I can perfectly see. I'm gonna fast forward to make sure there's no issues happening. I can see fast Ethernet 02 is always connected to this one over here. Where they are connected here doesn't matter. There's only one Ethernet port on a computer, so it doesn't matter here. But I can go in here, go to config, and go to the 02 fast Ethernet cable, and I can see that there is VLAN here. There's several options, but there's one that is default. So what we need to do is go to the VLAN database, and we can add a number, which is we're gonna add number 2, and that is isolated. I am going to call this, and then the number 2 is isolated in this table, and I'm going to go to fast Ethernet 02 and turn this on. What does this do? What it does is it creates a separate LAN on our switch. Our switch has many ports, many devices connected, and what we can do with these switches is make sure that they are disconnected from each other, that the ones on number 1 are all connected to each other and can communicate, but number 2 is a separate virtual LAN that is disconnected from all the other ones, and that only can communicate with devices that are also on number 2. Now we have a bit of a problem, because now what we could do is turn this one to number 2 or VLAN number 2, and then but then what is going to happen is these devices can't communicate anymore. So we add an extra switch, and what we're gonna say is we connect these two with each other, number 6 with this one with this one. I'll take number 6 too, just to make it easy for me, that I don't have to think about which number I'm going to use. And I'm setting this up at 2 isolated. And on the other device, we now need to do the same thing. Now, this one doesn't have a table that is the exact same. So we need to set this up to number 2, isolated, add. We have it set. This one is going to be also on fast Ethernet 2. And number 6. And this has been set up. So these are now connected to each other, but not to the broader network. I'm going to fast forward to get them all running. And what I can now do is look at the IP configuration here. Now there's a problem here because this device is the one we set up DHCP with. But this device is no longer connected to these because the F1 is still on a number 1 VLAN. We can even see that if we hover over this here, it's going to give the table. And so the fast Ethernet 01, we can see in this table that is over here, is on number 1. It's only number 02 and 06 that are on a different network. What I'm going to do for now is I'm going to make this a tiny bit bigger. Okay. And we have this table here. So this means these two can communicate, but we need to set up a static IP. And for this one, we can actually just use the regular normal, the computer environment if something is separated, because we're not going to particularly be using this anymore. So we can just call this 1.1. This will make a regular subnet mask. I'll just set itself as its default gateway, and then I will close. And now we're gonna go here. We're gonna go to this IP configuration, which was set up as DHCP because I copied all of these. They're by default on DHCP, but we're going to set these on IPv4, and this one we're just gonna go default to itself. I don't think I have to change this, but now what we can do is we can actually ping, paste and ping, and we are getting a reply. So I am now on the second computer and I can ping this computer over here. Now what I can't do is we already have DHCP set up. I'm going to open one of these. Desktop IP configuration. This is 0.55, but this is on a one network. What we should be able to do, if they were connected, I would have to be able to ping that guy. But now I will ping it and it's going to say, no reply, request timed out, and it's just going to keep saying request timed out. I'll forward here, and it just is going to keep saying request timed out. This means they are not connected on the same network unless there's something, just wrong in general. This is now correctly set up. There shouldn't be anything right now that is causing issues. So we know that this has been set up. So what did we do? We set up DHCP, we set DNS, and we set up our general VLAN. Now what I am going to do is I am also going to set up a router and make sure that these are connected to an external DHCP server, because that's also something we can do and something we can set up. We can make sure that our DHCP server, our DNS server, which is usually going to be something that is connected on a different device, which is going to be connected to something external, so you might be using cloud infrastructure, whatever it is, something like Azure or Google Cloud, whatever it might be. You're using one of these services. Well, what can you do? We can connect this to such a thing too. It doesn't have to be local. It doesn't have to be in the same building. It doesn't have to be in the same corporation, institution, enterprise, whatever it is you would like to call it. It doesn't have to all be in the same network. We can communicate outwardly to a different network on the WAN, on the internet, and then make a connection to it. And I will show you that right now. So what I will do now, I am going to set this up. I'm creating a router. I'm going to create a second router. So this is the router of this network. We're going to, of course, call these networks as we want them to be called. We're going to, I usually go 192.168.10.1. This is going to be, or maybe even O. We'll just write it like this. And what we're going to do, nope. Copy this, and this is going to be our second network. We've got a bug here. Yes. This didn't go to the right place. We're going to set 20. So I'm going to make sure that the default port on this guy is going to be 10. And here the default port will be 0. I am just going to add a single computer here, or even better, I am going to set up a server. And what I'm going to do is I'm going to make sure that these two computers are actually set by this server. In fact, I am not going to set up that these are set up. These are set up by this server. I'm going to make sure that these two guys over here are set up by the device over here. I'm even going to be so bold as to make this our third network. And again, I'm experiencing a bug. This one is going to be 30. So we've got one network, we've got two networks, and we've got a third network over here. I'm gonna connect these up. 05 is going to be connected with the 00 port. Is usually the one that I take as the default port. The same thing I'm doing over here. Fast Ethernet 00 connected with each other, and then I'm going to connect the 01 with the 01, and now these are connected, but they aren't routed properly yet, and we're going to see how we're going to do that in a second. But first we connected the FA here. I can apparently erase NVRAM startup config and running config, but that's not what I intended to do here. I can now set these two isolated as these FA05 so that these are connected with this device. Now they're not going to be connected with this one. It doesn't really matter. These are already connected. This is just for the purpose of demonstrating what it can do. I go to this one, I copy this guy, and now I am changing the default gateway, or setting the default gateway that I was just in a second ago. I did something already kind of wrong, or is it wrong? I need to set this guy to 1.2 because that's actually how we started doing this one. So I'm setting these as just, I'm not gonna use this 30 structure. I'm removing the 0 here everywhere because this guy here was already set up as 1.1. I do need to change what I configured here. As I said before, the default gateway is going to become 1.2. The same thing I'm going to do in my DHCP. My default gateway is going to become 1.2, no longer 1.1, because we're no longer using the server as the It doesn't even make any sense. No, I'm going to keep it at 1.1. It doesn't actually matter anymore. Because we're not setting these up as part of this network, we're going to keep these two separated. It's actually just fine. Not to make you confused, not to confuse any numbers. I'm going to keep these. Okay. This is this needs to be the 3 point. I'm actually just going to 3.0 because they're connected to this 3.0 part here, Ethernet, and these are going to be 3.0. Ooh, it's giving me an error. 3.1 on. It's on the network now. They're now connected here. I'm going to connect the O1. Which I have not added this as what I'm going to set here. Come on, man. Okay. 10.0 point 12.1 or 0.0, but these are going to become 1 and 2. Set. Okay, 10.12.1, and I'm again experiencing a bug. This is what throwing me. It's throwing me off right now. Delete. Yes. Okay. And the second one is going to be 12.2 because we're going to set up our table and make a hop. So 10.0.12 because I am router 1, router 2, just to make it easy to remember, 0.1. And this is going to be a 255.255.252 subnet. This makes it so that we are only looking and only have 2 IP address spaces to fulfill, which is going to be 1 and 2, and everything else is out of the question. I turn this on too. I go here, config, O1 is going to be the other guy over here. I'm just going to copy this, copy and paste it over here. This needs to be the same thing, 255.255.252. Again, easy, small subnet space, good for our 2 connections, 12.1 and 12.2 on their own subnet, making a clear separation so they can communicate easily. And this guy we were calling the 0.2 IP address 2.1. The default is okay, and we are now on our other DHCP server, and here we are going to config our IP. This one has to be static because it's a server we need to be able to look up again. Subnet is set. The default gateway is going to be this one, but we're going to set this one as a 2.10. This was just 2.10, so we have we can almost have the same here. We just need to add or remove a 0. This is the 10 device of our IP address, and then we are going to set DHCP on. Default gateway is this guy, but that's not the one that we are setting here. We are going to set 3.1. Why are we going to set 3.1? Because this needs to be the default gateway of these devices over here. And if I am not mistaken, the IP or the Ethernet one here has been set to 3.1, so that if they connect and get the DHCP from here, they can have it set like that. DNS server is going to be 2.10 for our server that is on this network. So it's going to, if it does a DNS lookup, it's going to look for it over here. To demonstrate that, and I think I did a big no-no. I actually made a mistake here. I can't switch. It's really annoying that I can't switch. 3.1 it was here. Control V. This is one going to be DNS 2.10. I'll make sure that this is set here. I'll do 50. Our first is going to be 3. And then we are adding this to this pool name already exists. Server pool number 2, we're going to call this one, because our regular one is just the one that is on this network, but we don't have any devices there. I'm just going to keep these two separated. It's just to show you too that there is the possibility to add multiple. If you're on different networks and setting things up for different networks, you know, it has to be like aligned with that network, and make sure that these are separate. I could make this a 4, etc., and add more networks, and they could all refer to this DNS or DHCP server to get their IP addresses, so you can do multiple networks with just one server. DNS is for in a second, and we are editing this one because this one we will do YouTube. Save. Yes. DNS, YouTube. And the address is the 0.10 of our server. So I guess we have everything set up. I believe it to be so. We'll set the DNS server to 10 here as well. Not that we need it. Well, okay. And now we need one more step, which is setting up our routing. We are looking, if we are looking for network 3.0. So this network 3.0 with mask 255.255.255.0. The next hop will be this guy over here, the 12.1 is the next hop we're going to take if we're looking for that specific network. Okay, that is set up. Now we're going to do the same thing. Can you please no static network. If we're looking for, it was actually right, 2.0 in this case, 255.255.255.0, and the next hop is going to be not this one, but the second one of our 10.0.12.2. It will be add, and now our routing should be correct. I think everything is on, everything should be fine. If I now go to this computer, I'll set up the simulation. If I go here, we'll see what it's going to do. IP configuration, we're going to go to this DHCP from what we set to static before, and we're going to play this one. It's going to set this to the switch. It's going to start looking for where it needs to be, and something is already going wrong here. I'm going to try again. Sometimes this gives an error, or the first try doesn't really work. I need to reset. Come on. DHCP again. It's requesting. It's going to go there, and the packages are currently dropped. Okay, we are going to take a look. Enable 1 second. We need to go for 1 second into the CLI because our packets are still being dropped. The thing we have to do here is this should be fine. We are going to the interface. I don't think it's giga. Yes, it does. It is gigabit Ethernet, gigabit Ethernet. And we're gonna write 02./1 because this is the one that we are going to change something on, interfacing on it. And then the next thing we're going to do is say IP helper address is going to be 192.168.0. This our computer is on IP address 10, so it's over there. I need to add double D's. Am I forgetting something? Okay. We say exit. And now we're going to do another try. We reset the simulation. We're going to go into our PC. IP. I know this is one is a little bit annoying because you constantly need to reset this. Now we're going to see if it goes anywhere. And it does not go anywhere. Reset the simulation. Reset. We're gonna try again. And it's probably going to fail again because what we do need to do is we need to set this address up here, right here. We're going to yes, okay, exit. I'm just going to switch so it resets. Normally it should reset. No, why are you not? No. One second. I needed to press config terminal. This is not what I can remember that I had to do last time. I'm going to go IP helper address, and I'm actually, I think this is kind of weird. Point 12. 0.0, I'll say 0.0. Or no, I'm going to go 0.2. I need to add another command here. Interface. Helper address, exit. Let's give it another try. I cannot remember this being an issue last time. Okay, every time you do this, there's always some issue. And it drops it again. Why? Do I need to set it to the full? It might be that it's dropping here somewhere, but it's not showing me properly. 192.0.2.0. Okay, exit. Reset. Start again. Sometimes this is very confusing because of Cisco Packet Tracer, because sometimes you need to actually reset it and then try again before it actually does what you want it to do. But my packages are being dropped here somewhere for some reason. It's set up correctly. Let's see where it's dropping. VDU, IP, DHCP. The DHCP server does not have a pool configured for the received port. It drops the packet. See, is it a server issue? Services DNS is correct. DHCP. Do I need to delete this one? I can't. But it can't be. Fuck. The first thing I'm going to do to debug this is well, first and foremost, I am going to reset the simulation. I'm going to set it to real time, and I'm going to see if I can actually even get a ping. From hour to 0.10. I get, oh wow. I'm going to fast forward this one. It's timing out, so there's actually something happening that makes it so that I can. I'm going to trace the route. Fast forward this one, and it's actually just timing out. So this actually, the problem is actually the router and something that I have as a setting here. It says 3.01. If I am looking for the number 2, which is what I am looking for here, it has to go through here. I have not made any writing mistakes, it seems. But I can't even connect to this one. Can I even? Oh wait, my ping is actually, I know why the ping is not working. I have not set, I've been trying to get to the DHCP. So do I 168.3.10? The default is this one. And then I am going to ping, and that should now actually work. I'm all to trace route. So yes, it receives them. That one here. Yes, it's getting over there. I'll fast forward this, and it's receiving trace complete. So it does get to the server. So what I got here in this package when I was trying that, it wasn't actually getting the DHCP from the router because it didn't have one set up for it. So I'm going to delete these. I'm just going to use the first pool. I'm going to try this again. The server is on 10, default gateway 3.1, 3, 50, save. My best guess, this is going to now supposedly should be working. But I also believe that there is a thing with the IP helper address that I need to set up, but it's getting lost here. Might be that I need to do it here as well. But it should work by now. It could be just like a minor detail that I'm doing right now. This is excellent work when it comes to debugging this stuff, but can we please go to DHCP? I'll fast forward and the request is failing. I'm going to go to static simulation, DHCP, try again, go, and it's dropping right there. It didn't even show me what's happening here. Receives the frame. The frame's destination MAC address matches the receiving port's MAC address, the broadcast address, or a mobile. Up, so it's going. The device looks up IP as entry device packet UDP. The device decapsulates the PDU from the UDP segment, and then here it is that the DHCP received a DHCP discover packet. The DHCP server does not have a pool configured for the received port. It drops the package. Is it really that it's just like two? This can't be right. This cannot be. This is not the way I set it up last time. This shouldn't be an issue. And again, no. Nope. It failed again and again and again. So this is not the issue, which I thought maybe would possibly be the case, which I already knew that wasn't going to be the case. Do I have this configured? 2.10, default 2.1, DNS, yes, subnet. Something along the lines here is going awfully wrong. I'll try it. It says specifically it doesn't have something set up. Aha, I see. I think this is, or am I, no, this is right. And this is right too. 3.0. Two 2.0, which is over here. I think I just figured out where I went in the wrong. Okay, so what I think, and I'm going to see if this is the one, the interface, gigabit Ethernet. The last time I used this and I was just trying to figure this out again, and the thing is that I am pretty sure that what I did wrong is that this 01, the IP is not, the helper address is not supposed to be the line where you go to it, but the one where you receive it. So I need to set up the interface gigabit Ethernet here when I receive on this line the IP helper request. So I think it's like IP helper address and then go 192.168.2.10. This should be exit. Should be now. I'm going to reset the simulation. I'm going to DHCP. Should be that when it receives it on this line, that it's then forwarded to. Okay, here we go. Yes. Bam. Okay, so minor detail, minor problem. Now, one of the things that is a bug or something, an issue in Cisco Packet Tracer right now, I don't have this IP address. All I have to do is reopen. Or no, rather, I need to reset this simulation, sorry. And then it will show me that it has received this IP address. I can now do the same thing for this guy, but I'm not going to do this in simulation. I'm going to do real-time IP. I'm going to set up DHCP. I'm going to forward, and it has received from the server the next address. So to recapitulate, what we did just right now is we set up these two routers, which are connected and hopping to each other. That was fine. I could ping to this one if I set the static IP, but we wanted DHCP. The thing that I went into the wrong here was this line, the IP helper that you need to set up in CLI is something that needs to be set up on the line connecting to the actual network and not the one going out of it. So you have to go to gigabit Ethernet 00, which is the one that is connected here. We say gig 00, and then IP helper address to 10 is our server address, so it knows how to route to that one by the table that we set. But we say, okay, you are sending a package to this server, so it knows, okay, I need to hop here because of the table, and then you need to exit it here, and then you have this thing working. So now these two are getting a DHCP from this guy, and these two are getting one. If I set this to IPv6 is not necessary. This one is connected to this. We see that by 1.55 is not one that this server is set up to receive. And this is how we are routing with DHCP across our network. I hope this was informative. I hope you understand this now. I'm leaving in actually me debugging the actual thing. Because I think that's actually very important. If you run into problems, there's always going to be possible. It is something that is part of this, doing this every time. It's just something, a number you're wrong, a connection that you're misinterpreting, or that you're maybe you need to look something up. You know, I've been programming for many years. I still sometimes need to look things up. You can see this live in action, and I hope this was informative for you and that you know now how to set something up like this. I think the next one I will do is going to be RIP routing, and I will see you next time.